Hey guys, Mr. O'Sullivan here. Hey, we're going to go ahead and go through um, AB number 5 homework problem and dive right in. Again, thanks to Jeff Osborne who came up with this problem. All right, so if we dive in, we're looking. Alice and Bob are riding the scenic skyway at Knables Amusement Resort. Alice's position in relation to the entry to the ride is given by the function a at t. Got to be a little careful here because a at t, that's Alice's position function. And then Bob's position in relation to the entry to the ride is given by b at t. Alice's velocity measured in meters per minute can be modeled by the function a prime at t is equal to negative 3t squared plus 24t plus 2 on the time interval from 0 to 8 minutes, closed interval, which is the length of a ride. Bob's velocity, b prime at t, measured in meters per minute, is modeled by the data in the table below. At time t equals 0 minutes, Bob gets on the ride. In other words, b at 0 is equal to 0. So we're given an initial condition for Bob's position at time 0. He is at position 0. Okay. So first thing we're asked to do, part A, find Alice's acceleration at t equals 3 and indicate units of measure. Okay, well, I come back and Alice's velocity is, so I'm just going to write so I don't screw this up. Velocity is a prime at t is equal to negative 3t squared plus 24t plus 2. And if I'm looking for acceleration, I basically want a double prime at t. It's going to be negative 6t plus 24. And so acceleration at time 3 is equal to negative 6 times 3 plus 24 and indicate units of measure. Well, if that's acceleration, that's going to be velocity is meters per minute. So that is going to be meters per minute squared. Okay, part B, using the data from the table, approximate Bob's acceleration at t equals 3, indicate the units of measure. Okay, well, to approximate Bob's acceleration at time 3, I'm going to look here on the time row, and time 3 would be located right there. So I'm going to look at kind of those two ordered pairs. And so really I'm looking for the average rate of change of velocity. I'm going to use that to approximate acceleration at t3. So this is really just going to be b prime at 4 minus b prime, again, that's velocity, at 2 over 4 minus 2. Can't leave it like that. So I have the function notation, got to take care of that. So b prime at 4 is 46 minus b prime at 2 is 36 over 4 minus 2. That's a numeric answer. And I also want to indicate units of measure. Well, again, that's still going to be in meters per minute squared. Okay. All right. Onward and upward. Part C, use a right Riemann sum of the data from the table, approximate the total distance in meters that Bob traveled on the time period from t equals 0, t equals 8. All right, well, my right Riemann sum is going to approximate the total distance, which is given by the definite integral, lower bound of 0, upper bound of 8, and total distance is going to be the absolute value of Bob's velocity, which is given as b prime at t. So it's the absolute value of b prime at t dt. I'm going to approximate that using a right Riemann sum. And so what I'm going to do, just mark out change in t. That looks like, yeah, that's 2 units, 2 minutes each time. And then it's a right Riemann sum. So for each interval here, I want to circle the right one. and I'm going to ignore that. So then I'm just going to pull this in. My right Riemann sum, since my units, my delta t, if you will, is all the same, what I can do is kind of factor that out. Put that 2, and then times 46 is 46 plus absolute value. Now here's where I'm sure students might make a mistake. Since this is the absolute value of b prime at t, I'm really, change that up. Just change that to absolute value of negative 34, and then plus absolute value of negative 2. These last two values here are negative. I need to change them to be positive in order to come up with the total distance. Total distance, not the displacement, the total distance. Okay. If I want to be consistent, I could put all that, everything in absolute value. Okay. And didn't say anything about units. I'm just going to keep on rolling through that. Part D says when Bob gets on the ride, Alice is already on the ride. Assuming that Alice is 35 meters from the entry to the ride at time t equals 0, or A at 0, Alice's position at time 0 equals 35, find the value of A at 2, which is Alice's position at time t equals 2 minutes. Indicate units of measure. All right, so I'm looking for Alice's position at time 2. So I know that A at 2 is going to be equal to 35, which is A at 0, plus the definite integral from 0 to 2 of Alice's velocity, which is given as A prime at t. And that's right there, negative 3t squared plus 24t plus 2. 3t squared plus 24t plus 2 dt. Then I'm just going to simplify that. Actually, I got to evaluate the definite integral. So it's 35 plus the antiderivative is going to be negative 3 t to the third over 3. That's going to cancel out my 3's, plus 24 t squared over 2 should be 12 plus 2t. Bring my bounds across. Okay. That's going to be equal to, got to keep going one more step, 35 plus, and I'm just substituting in my upper bound, negative 2 cubed plus 12 times 2 squared plus 2 times 2 minus lower bound would be 0 for everything. That's a numeric answer. Indicate units of measure. That's going to be in meters. Okay, that would make sense that her position is in meters. And then finally, part E, use a trapezoidal sum and the data from the table, find the value of B at 6, which is Bob's position at t equals 6 minutes, indicate units of measure. Okay, well, we're doing a similar thing. B at 6 is going to be equal to 0, which is given as an initial condition. B at 0 right there is equal to 0 plus, and I want to go from 0 to 6, and that is going to be Bob's position, and so that would be B prime at t dt. Okay, now B prime at t, those values are given in a table, and I want to use a trap sum to come up with that. So that's going to be, just going to do this right below my 0, not going to matter. And then my trap sum, now my table, I'm going from 0 to 6. So if I clean this up a little bit, I want to ignore that last one. And again, my delta t's are all going to be 2. So what I can do is I can factor that 2 out, and then it's going to be 2 times it's a trap sum. So what I'm going to do is take 3 plus 36, divide by 2. Actually, I'm not going to factor that 2 out. I've only got 3. I'm just going to do it the long way. Plus, again, 2 Next one over is going to be 36 plus 46 over 2. And the last one is 2. And the last one's going to be 46 plus negative 34. It's negative 34 over 2, average of those two, because I'm looking for position, not the total distance. So that's going to be Bob's position at time 6. All right, hope that helps. Thanks, guys.